Example 4 is a three-dimensional problem. A communication tower is 35 meters tall. David is due north of the tower, and he measures the angle of elevation to the top of the tower as 70 degrees. Brenda is on a bearing of 175 degrees. So bearings start at north and go clockwise. And she measures the angle of elevation to the top of the tower as 50 degrees. To the nearest meter, determine the distance between Brenda and David. Okay. So, first of all, I'm going to take a north, south, east, and west little compass thing and pretend I put it down on a piece of paper to make it three-dimensional. Are you okay? With that idea? Normally when you do north, south, east, and west, it would be straight up and down, right? But if you imagine a three-dimensional picture where you lay it down on a table, because what I'm going to do is I'm going to draw my tower right here, 35 meters tall, coming out of the ground. Now does that north, south, east, and west make sense? Not really? So now where's David? David is due north. So David would be along here. Maybe David's right there. Okay. David measures the angle to the top of the tower to be 70 degrees. Now we're dealing in three dimensions here, so this is a little bit hard. Can you see that that is a 90-degree angle? It doesn't look like a 90-degree angle the way that we've drawn it, but we could take this triangle here and redraw it with the tower and 70 degrees, this being David right there. A 90 degree because the tower is going straight up and down. Again, it's nice to color code things. Brenda is on a bearing of 175 degrees. So where's Brenda on this? Bearings start from north, travel in a clockwise direction. Can you see that south would be 180 degrees? So Brenda, and I'm going to use a different color for Brenda, would be there with this angle in here being 175 degrees. I'm going to use B for Brenda, D for David. That's good. And then Brenda measures her angle of elevation to the top of the tower, this angle right in there, to be 50 degrees. Again, in three dimensions, it's difficult to see that that red lines and the blue line, I didn't use a ruler.
Yeah, no, but like, if the red line's on the y-axis, then how did it curve around the y-axis to get to the top of the y-axis?
Okay. So again, I could redraw the red and the blue off to the side. We've got our tower. Oops, I'll draw it with blue. We've got our tower that's 35 meters tall. We've got Brenda over here. Angle of elevation 50 degrees. This is a 90 degree. It's not the Leaning Tower of Pisa.
Wait, would that be like a trick question if we get it?
With the Leaning Tower of Pisa, it would be more difficult, yes. We want to solve. This is the question. How far are Brenda and David apart? Okay? So I'm going to redraw the triangle that has the x. Okay, we want to solve for x. We've got a green line there and a red line here. And we know that this angle between them is 175 degrees. So if I look at what I want to solve for, which is the purple x, on the picture that I've drawn, I don't have enough information. I can't use sine law or cosine law because I don't have enough information in this triangle. Can't do anything with that triangle yet. But I look at my other triangles. With the green triangle in the tower, can you solve that triangle? Yes. Okay? In order to solve a triangle, you need 3 pieces of information, and one of those pieces of information must be a side. Okay? Right now, on that green triangle, I have one side, I have a 90 degree and a 70 degree. I have 3 pieces of information. I can solve that whole triangle. Which side is going to be important to solve for? The bottom part. So I'm going to try and solve this first. I'm going to call this side little d for the distance for David. And I'm going to call this side little b for the distance that Brenda is away. So what are we going to do first? We're going to find D and B. What kind of triangle are those? They're right angle triangles. We can use grade 10 SOHCAHTOA. Okay? If I'm using the 70 degrees, I'm going to use tan. Tan of 70 degrees is equal to the opposite, which is 35, over the adjacent, which is D. And so D will equal 35 over tan 70. Multiply both sides by D, divide both sides by tan 70. Type that into our calculator. 12.7. So this side here is 12.7. That tells me on this triangle, this side is 12.7. Because I want to keep all of my decimal places, I'm going to store this. And since I used the letter D, I'm going to choose the letter D as well. So now 12.7 is stored in my calculator as the letter D. The store button gives you the arrow. Okay? Finding little b will be the same thing. Tan of 50 degrees is opposite over adjacent. So b will be 35 divided by tan of 50 degrees. Go to our calculator. 35 divided by tan of 50, 29.4. And I'm going to store that as the letter B. So we figured out this side, which was D, is 12.7, and we now figured out this side, which is B, which is 29.4. So one of the skills that this question requires is, first of all, on a piece of paper, can you draw a diagram that's 3-dimensional? Okay? Without that, you're not going to be able to break things down. Once you've drawn it three-dimensional, can you look at the separate components, see how they're related, and then we use the green and the blue triangle to find how far away David was from the tower. We use the red and the blue triangle to find out how far Brenda was away from the tower. And now we look at the triangle on the ground with David being 12.7 away from the tower. I'm going to label this point as T for tower. Brenda being 29.4 away from the tower. And we can now solve for x because we have three pieces of information, and at least one of them is a side. So we say, can I use SOHCAHTOA? No, not a 90-degree triangle. Can I use the sine law? No, I don't have an angle on an opposite side. I have to use the cosine law.
Can't you just like add 12.7 and 29.4 together?
Well, if I was walking from Brenda here to David here, I think it'd be quicker to take the purple route than it would be to take the red and the green route. So I'm going to say that the purple route is going to be shorter than adding the two together. Okay? So now we can solve for x. Since we're using the cosine law, x squared will be 12.7 squared plus 29.4 squared minus 2 times 12.7 times 29.4 cos of 175 degrees. One of the advantages of storing my values in there is the 12.7 was d. So instead of going 12.7 squared, I can go d squared plus b squared minus 2 times d times b cos 175. 1770. And square root that answer, 42.07. How much are we supposed to round to? To the nearest meter. So to the nearest meter, 42 meters. This is the hardest question this year?
Yep.
Harder than that axis of symmetry one with the two equations? Yeah? Hardest question of the year. Well, here's two to practice. 9 and 12. I'm going to just take your screen here. Let's look at the entire page and recap what we did. Okay, so looking at the entire page, we drew a three-dimensional picture to get an idea of what was happening. We broke down the three-dimensional picture into the three triangles that were involved. Okay, there's the triangle where we're solving for x, which is the distance between them, but we didn't have enough information in that triangle, so we had to use the green and blue and the red and blue triangles to find some information first. Once we found little d and little b, we had enough information with the purple triangle to solve for x. And there we had it. It's not so bad.
That's the drawing part. That first part's the hardest part.
Will this be like 5 marks or on a test or something?
Well, you make it like
Yeah, it might be 4 or 5 marks, yeah.
make it like 2 marks so I can just like you lose my respect. That's all.